Hi, we have examined the Karnaugh map representation of the functions that was that frame. While we are examining this frame, we also examined the neighbor cells in Karnaugh map in this video. So in this new video now, we will be examining subcubes and give some examples for the subcubes. That is the second terminology that we are going to use. So the first terminology is the neighbor cells for the Karnaugh map. Second terminology is related with mth order cube. So let's move to this open board now. You see there is a transformation to do that. Here you are. So let's start with the definition. This should have been order subcube, we call it subcube. Mth order subcube includes 2 to the power m number of ones, values, these 7 values, cells made a group. So that means, example, if you consider m equal to 2, 2 to the power is 4, 4 1 values cells made a group. This group is a second order subcube, we're going to call it. But not any second order subcube has got 4 ones in it, but any 4 does not make a subcube. So we're going to separate those from the others. How we are going to separate is explained here. If each cell within the group has m number of neighbor cells within the group, then these true mean terms are set make a mth order subcube. It might be seeming a bit confusing, but when we give an example, then it becomes simpler. So the smallest subcube is m equal to 1. If m equal to 1, 2 to the power m is 2 to the power 1 equal 2. So we are going to consider 2 ones now. 1 1. In the Karnaugh map, these 2 ones, each one must have a 1 neighbor. So why 1 neighbor? Here you are 1. The order determines the neighbor numbers. So for example, this 2 1, consider this one. This one is neighbor to this one, and this one is also neighbor to this one. So for each one there is a 1 neighbor. Then these 2 ones make a first order subcube. For example, if you consider, let's make a different color here, this 0 and this 0. Sorry, it's not 0, of course it is 1. Those 2 ones does not make a first order subcube. Why is that? Because they are not neighbor to each other. But these 2 is neighbor to each other. For example, these 2 is also neighbor to each other. Understand? Any 2 ones does not make a first order subcube. But if these ones has got a property which are neighbor to each other, then it is called these 2 make a first order subcube. When m equal to 2, so we are going to talk about 4 ones, 2 to the power 2. So this operation here, 2 to the power 2 is equal to 4. So we are going to deal with 4 ones. So a group of ones which has got 4 ones in it. So there must be some property related for these ones. What is this property? Is this: each one in this group must have 2 neighbors in it. Each one. You're going to repeat it for each one. For example, these 4 ones here, they make a second order subcube. Why it is second order? That is the order 2 to the power 4, so it is a second order. How I am going to check whether this is a cube or not, subcube or not? So each one here, this one for example, is neighbor to this one, 1, is also neighbor to this one. So m equal to 2, that means the order of the cube, also the number of neighbors for each one, isn't it? For this one, this neighbor and this neighbor, 2. For this one, this neighbor and this neighbor, 2 neighbors again. For this one, there are 2 neighbors. So each one within this group has got 2 neighbors. Therefore, these 4 ones make a subcube. For example, the 4 ones here, we've got 4 ones here. These 4 ones doesn't make any subcube, second order subcube. Why is that? Because this has got 1 neighbor only, not the second neighbor. We said each one within this group must have 2 neighbors. So it doesn't work. Therefore, those ones is not a second order subcube, but this one is a second order subcube. Let's see the relation between second order subcube and the operations. Let's do it. Operations, just remind you, variable elimination operation. For the first order, these 2 ones means to represent an operation like that. So let's examine it for these 2 ones here. So let me clear this area. I'm talking about now these 2 ones. Okay, this one here is a product term. This product term is x1 prime, x2, x3 prime, x4 prime. How I wrote it, this one related with this column and this row, isn't it? So for this column, x1 value is 0, x2 value is 1, that's why x2 itself, x3 is 0, then prime of it, x4 is 0, then prime of it. So let's come to this one. The corresponding product term to this trimming term is x1 prime, x2, and x3 prime because of that 0, and x4 because of that 1 here. If you look at these 2, this is capital A, this is capital A, and this is small a, and this A prime, and this is A. So when you add those up, this A, small a disappears, and what is left is x1 prime, x2, x3 prime. So when we are talking about first order subcube, represent an elimination operation directly here. If you consider the second order subcube, for example this one, this is going to be one variable elimination operation repeated case. So let me see it now. For this one here, make it different color, maybe it's better, isn't it? Make it, so this one here, x1 prime, x2 prime, x3 prime, x4, 0, 0, 0, 1, prime, 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 x4. So this one here, x1 prime, x2 prime, x3, x4, and this one here, x1 prime, x2, x3 prime, x4, x3 0, x1 4, that's why I wrote that. So the last one is, so that one, that is x1 prime, x2, x3, x4. So you've got four product terms now. If you consider those two now, x1 prime, so x3 here. So if you connect those two, operation 1, x1 prime, x2 prime, x4 are the common part. x3 is changing the value, so x3 is going to disappear. Elimination of one variable. So if you consider now these two, x3 has gone. What is left? x1 prime, x2, x4, isn't it? So these are the common part. x3 is changing, so x3 disappeared. What is left is this. So if you compare these two now, x1 prime, x2, oh sorry, x4 is common, isn't it? Prime and itself. So x2 is changing the value, so x2 is going to disappear. What is left is this. So that means this second order subcube represent repeated one variable elimination operation. So one operation and the second operation, the first operation x3 disappears, in the second operation x2 disappears. So there is a direct relation between the subcubes and the variable elimination operation. So you can increase that, the third order subcube to the power 3, you're going to think 8 ones. Each one within this group must have 3 neighbors. For example, let me clear this area once more. In the last one here, this 4 ones and these 4 ones make a subcube. And third order subcube, I should have said. These 8 ones, for example, they do make a third order subcube as well. But if you consider, let me get in blue color, these 4 ones and these 4 ones. These 4 ones, 8 ones do not make a third order subcube. The reason is, in the definition, each one must have 3 neighbors. So it is not true for the blue one, but it is true for the red one. So I am going to explain it for the red one here. So I am saying these 8 ones make a third order subcube. How I am going to prove it is easy. Consider this one is neighbor to this one 1, neighbor to this one 2, neighbor to this one 3, isn't it? This one and this one. Consider this one, neighbor to this one 1, neighbor to this one 2, neighbor to this one 3. So if it repeated for all the ones, you're going to end up with each one within this group has got 3 neighbors. Therefore, these 8 ones make a third order subcube. That is the subcube. So if you write the function values, each product term corresponding to these ones, you're going to have 8 product terms like that. At the end, you're going to have 3 one variable elimination operation, and you're going to end up with x1. So repeated one variable elimination operation 3 times repeated, you end up with this result. So what does this mean? You are reducing the number of product terms. Instead of 8, you've got 1 here. Also, you are reducing the number of variables within each product term that lead us to the product terms of a minimal function. So that means that lead us to the prime implicant concept. So that's the end of this video then.